Tonight we are going to look at section 1.8, the algebra of functions and function composition. Most of this should be review from your algebra days in algebra 1 and algebra 2 in high school and such, but we may stress a few themes that they didn't do back then, so if you pay attention, hopefully you'll pick up on these and of course ask questions when you're unsure. The first four operations, of course, adding, subtracting, multiplying, and dividing, are categorized under sum, difference, product, and quotient of functions. Given functions f and g, the functions f plus g, f minus g, f times g, and f divided by g are defined in the following ways, as you might expect. That f plus g of x is f of x plus g of x, f minus g of x is f of x minus g of x, f times g of x is f of x times g of x, and f divided by g of x is f of x divided by g of x, according of course, g of x cannot be equal to 0. Now, when you have two different functions, they might have different domains. So what does that mean as far as the domain of these new functions we're creating by adding, subtracting, multiplying, and dividing? The domains of these functions, these new functions here, are all the real numbers that are in the intersection of the domains of the two functions f and g. And of course, in f divided by g, we're going to restrict the domain to exclude anything, any value of x, that if we plug it into the denominator, that makes the denominator equal to 0. So let's start off first off just by looking at how we create these functions. Now in this case, the domain of f is all real numbers, the domain of g is all real numbers. What about f plus g? Well, it'd be the intersection, all real numbers here, and f plus g of x would be equal to f of x plus g of x. So that would be equal to the opposite of the absolute value of x plus 4. And we have seen functions, and we've looked at functions when we were graphing, when we were reflecting, and we were translating and such. And we have this new function, f plus g of x is equal to the opposite of the absolute value of x plus 4. Now let's look at its specific values. Let's give three functions here. F of x equals 4x, g of x is equal to the absolute value of x minus 3, and h of x is equal to 1 over x plus 1. So we're going to determine at specific values here of x. F minus g of negative 6 means, g minus f of negative 6 means g of negative 6 minus f of negative 6. So we plug negative 6 into the rule here, and we have the absolute value of negative 6 minus 3. That would be the absolute value of negative 9 minus f of negative 6. I would go back to here. F of negative 6 would be 4 times negative 6, which would be negative 24. So this becomes 9 plus 24, or 33. So we evaluate each of the functions at that value, and then we subtract them. G times h of 0 would be g of 0 times h of 0. G of 0 is the absolute value of 0 minus 3, so that would be the absolute value of negative 3 times h of 0, which would be 1 over 0 plus 1, which would just be 1. So this is equal to 3 times 1, or 3. And the third one here, h divided by f of 0, would be h of 0 divided by f of 0. Well, h of 0, I just did that a second ago. That turned out to be 1. F of 0, well, that would be 0. And you can't divide by 0, so this would be undefined. So in this case, 0 would not be part of the natural domain for h divided by f. Here's another example. Given functions f of x is equal to x plus 3, g of x is equal to x squared minus 9, and h of x is equal to the square root of x plus 1, let's find g minus f of x and state its domain in interval notation. Now remember, the domain will be the intersection. So let's look at each one of these individually. The domain of f, I'll just write it above here, would be all real numbers. The domain of g, also all real numbers. But h is a little bit different because x plus 1 can't be negative. That means x has to be greater than or equal to negative 1. So the domain of h would be from negative 1 to infinity. So we keep that in mind here. Now it says find g minus f of x. Since g and f are both have domains of all real numbers and we're subtracting, its domain is also going to be the set of all real numbers. So g minus f of x is g of x minus f of x. So g of x is x squared minus 9 minus parentheses here around f of x, two terms, x plus 3. So this is going to be x squared minus 9 minus x minus 3, or x squared minus x minus 12 when I combine my like terms. And as I mentioned here, the domain, let's see, g minus f would be all real numbers. And there's the two parts of my answer. For part B here, it says g times h of x. So what we're going to do is we're going to multiply g and h here. This would be g of x times h of x. I don't think we need the second set of parentheses. We'll get rid of those. And this would be equal to g of x, which is the quantity x squared minus 9, times h of x, which is the square root of x plus 1. Well, there's really not much you can do to simplify this expression. Here we had some like terms, but here we have the radicals, so we don't have those like terms or like radicals. So I would probably leave it like that, but my domain here will be the intersection of these two, and so that means that my domain would be the same as the domain of h. So the domain here of g times h would be from -1 to infinity. So there's this answer and there's this answer. Now we got to get down here to h over g of x, and we're going to state its domain. So here's h over here, and here is g right here. So this would be h of x over g of x. So that would be, let's see, h of x is the square root of x plus 1 over g of x, which is x squared minus 9. Well, I have two things to keep track of. Of course, this can't be a negative number underneath, so we have this restriction here. Now this guy, its domain would be all real numbers, but you can see that there are two values of x that would make this equal to 0, 3 and -3. If we set x squared minus 9 equal to 0, we get those two values as well. So we'll have to throw those two values out. Now -3, I don't have to worry about it because it's not in the domain of h, but +3 is. So I can't really simplify this. This would be my answer for the h of x divided by g of x, but my domain of h divided by g would be all of these numbers here that's in h except for 3. So I would have to go from -1 to 3, parenthesis, and then from 3, parenthesis there, to infinity for its domain.